Okay, continuing on talking about inverse functions, we want to start by looking at what's called the horizontal line test. The horizontal line test is used to determine whether or not a function will have an inverse. And all the horizontal line test does is it says that if no horizontal line touches the graph in more than one place, then the function will have an inverse. So as long as you can draw horizontal lines that don't touch the graph more than once, you know your function has an inverse. If any horizontal line hits it more than once, then there is no inverse for that function. So for example, if we look at these three graphs, okay, if I look at the first graph, there's no horizontal line that I could draw that's going to hit that graph more than once. Okay, so what that tells me is that the inverse, f inverse, exists. Okay, I know that function will have an inverse, whatever it may be. Okay, if I look at the second graph, okay, if I draw in a horizontal line here, I'm hitting the graph in two different places. What that tells me is this function does not have an inverse. And the reason being is that if you think about what we talked about with the graphs, that when I have an inverse function, the x's and y's switch places. The domain and range switch. Switch. So if I were to think about the inverse of this function here, the second one, the inverse is going to turn. It's going to look something like this, where the u is now going to be lying on its side. Okay, and if I do that, then that purple graph is no longer a function. So that means I don't have an inverse function for the original function f. Because when I interchange the domain and range, I end up with something that fails the vertical line test, which means that it's not a function. Okay? And if we look at the third one, again, if I draw in a horizontal line, here are three different places where that horizontal line intersects my graph. Okay? So again, f inverse does not exist. Okay? There is no inverse for that particular function. Now, if a function passes the horizontal line test, then we say that that function is one-to-one. Okay? So a one-to-one function is one that passes the horizontal line test, and that no two ordered pairs can have the same y value, the same function value. Okay, so only one-to-one functions have an inverse. Okay, if the function is not one-to-one, then there is no inverse function. Okay, let's consider the function f of x equals x squared minus 1. Okay, think about the graph of that function. We know that that function is going to be a quadratic, and that the graph of that function would look something like this. Okay, coming down to 0, -1. So looking at that function, does that function have an inverse? And the answer is no, because if I draw a horizontal line, I hit the graph in two different places. So because this function does not pass the horizontal line test, it doesn't have an inverse. So in order to ensure that we can take the inverse, what we have to do is we have to restrict the domain. So what we're going to do is we're going to say, okay, here's our function x squared minus 1, but we're only going to use x values that are greater than or equal to 0, which in effect will take and erase part of our graph. So the only part of the graph that we are now going to be concerned with is just this piece here. Okay? So our new function with our restriction is going to look something like this. Okay? And now we will indeed pass the horizontal line test, and we will be able to find the inverse function. So now I can go and find the inverse by interchanging my x and y, and then solving for y. So x plus 1 is y squared, which means y is equal to the square root of x plus 1. And if we think about what the square root of x plus 1 looks like, remember that's our square root function. It's been moved 1 unit to the left, so it's going to look something like this. Here's our f inverse. Okay. So notice again that our original function here had the point 0 and negative 1, and notice on our inverse we have the point negative 1, 0. There's that interchanging of the domain and the range. Okay, let's say we have the function f of x equals the quantity of x minus 2 squared for x greater than or equal to 2. And we want to find the inverse. Okay, so to find the inverse, we're going to change f of x to y. And then we're going to switch or interchange the x and the y. And now we have to solve for y. Okay? So to get rid of the square, we're going to take the square root. Okay? And normally we would have a plus or minus square root. Okay? But up here we said the x's were greater than or equal to 2, so we know we're only going to use the positive root. So now to solve for y, I have square root of x plus 2, which tells me that f inverse of x is equal to the square root of x plus 2. Now if we were to go back to the original function and look at the graph, okay, the graph is going to look something like this, where we're at 2, 0. So our domain we know is x is greater than or equal to 2. What is our range? Our range is our y values, okay? So all of our y values are greater than or equal to 0. And remember, we talked about that the domain and the range of a function and its inverse switch places. So the domain of our inverse function is going to be all x's greater than or equal to 0. Because when we take our f inverse, we're going to flip-flop these two. So now the range, which was y greater than or equal to 0, now becomes our domain, x greater than or equal to 0. Okay, so let's kind of sum up what we've learned about inverses. Okay, first, remember that the composition of a function and its inverse in both directions, whether it's f of f inverse or f inverse of f, have to be equal to x. If both of those are equal to x, and that means they are in fact inverse functions. We can use the horizontal line test to determine if a function actually has an inverse. Okay, so if we've got a function, we want to know its inverse. The first thing is to look at a graph, use the horizontal line test, determine if the inverse even exists. If it does exist, we can find the inverse by interchanging our x and y, and then solving for y again, and then changing our y back to function notation and writing it as f inverse of x. And remember that sometimes we must restrict the domain of a function f in order for its inverse to exist, like we saw with those quadratics. Okay, we have to restrict the domain in order to end up with an inverse function. Okay, so we'll kind of recap and answer any questions in class tomorrow.